And first, I will do a very short introduction to machine learning, like what is it, when and why to use it, and how do you use it at HPC settings for our Matlab and Julia. So you know about machine learning. Everyone knows something about it. But what is it?
I've heard of it, but I do
Yes.
not know exact
Yeah, but
yeah,
you know about it. I mean, everyone has heard about it
heard
at
of it.
least.
Yes, I
Yes.
have.
So what is it? When and why would you use it for your research? So machine learning is a subtopic of artificial intelligence and is generally used to make predictive or decision models from data instead of programming them explicitly. And there is a lot of overlap between, for instance, machine learning and data mining, and they often use the same methods. But machine learning focuses on prediction based on known properties that we have learned from training data. And it uses data mining method when unsupervised learning or during pre-processing steps. Whereas data mining, it focuses on discovery of previously unknown properties in data, and it uses many machine learning methods, but with different goals. You have definitely also heard the word large language models, and they are a subset of machine learning that uses learning patterns from data and builds on neural networks, and those belong more under deep learning. So you can see it as AI is this larger block, and a subset of that is machine learning, and a subset of machine learning is deep learning. So they are all AI. It's just that there are subsets of it. And this text I have here, I mainly took that part here from Wikipedia, and that summarizes nicely that supervised learning is a mathematical model of a set of training data that contains training examples that are inputs and desired outputs. So you have classification of images, of diagnostics perhaps, and this target is then categorical. So you classify something. And then you have regression in this supervised learning, which does predictions and forecasts. And the target of this would be a numerical. Then you have unsupervised learning. And when you do unsupervised learning, you find structures in data that hasn't been labeled, classified, or categorized. So you identify some commonalities in the data, and then you should react properly based on the presence or absence of such commonalities in a new piece of data that you get. And here you have something called clustering, and there you have recommendations, targeted marketing, and things like this belong here. And dimensionality reduction, you will discover structures in your data. You have big data visualization. Can you compress your data, leave out parts of it, and still get something reasonable, etc. And then there's one more approach, which is reinforcement learning. And that looks at how software agents take action in an environment in order to maximize some notion of cumulative reward. And this is for when you do real-time decisions. It's used in game AIs, in robot navigation and things like this. So this is where you need to do something quickly based on your surroundings and the data input. So when should you use ML? Because people use it for many things, and also many things where they maybe shouldn't. But it's really good when the tasks you have are too complex or too dynamic for a traditional algorithm, when you cannot really write a program, or at least easily not do that in the normal way when you program something, or when you cannot really define a set of rules to solve a problem. And good examples here are, for instance, image recognition. or spam detection and things like this. It's also good if you have tasks that involves a large amount of unstructured data. Again, images, audio, etc. In these cases, machine learning is good. And it's also good when you need to be able to adapt to new information that comes in over time. So machine learning at Swedish centers. There are packages installed for many of these languages. Python has many packages for machine learning. R has some. Matlab has some. Julia also has some. None are installed at the centers, but you can install them yourself. And here we'll look a little bit about how to find these packages for machine learning. I had mainly focused on how you find the R packages because that's the one that has most of the packages. There's also an example of how we would use Matlab with machine learning and some examples for Julia. I will only cover any of those briefly. If you're interested in Python and Python for machine learning as well, then we have a course on Python. There's a first 1 day's introduction to Python, and then we will have some days of using Python in an HPC environment. And that looks at not just machine learning, but also Python with GPUs and with big data and pandas, many things. It's a mixed course on Python at Swedish HPC centers. So let us move to R, which I will go through somewhat quickly. Is R suitable for machine learning? And yeah, there are packages for it. Many people use it for it. What tools are installed at HPC centers and how do you run them? So I'll just start out with a short intro to this and a little bit about the workflow and tools installed, and then show the structure of the batch script. There are some examples, and that is the only thing we'll look at here. So R has quite many packages that are made for the machine learning. And you also know R for statistical capabilities for analysis and interpretation of data. So this is very useful to develop and deploy models without having to write a lot of code yourself. There are many good packages for machine learning and for data science, and I have tried to list some of the more popular ones and what they do. And well, there's probably no reason to sit here and read them, but if you do machine learning with R, then you probably have heard of some of these. And these are generally available at the Swedish HPC centers, with NAISS being the main difference there. So what ML tools are installed? Well, you can find them with the module Spider, but the problem is that in general, they are either in R directly or they are in a number of bundles that are installed. And at NSC, there is basically no packages in general for R installed. You install most or everything yourself. There's only like 30 packages. And of machine learning packages, there's only random forest. PDC has all of them within R, but only in the R442 version. Some of the other versions have little or none, but that version has many. C3SE, the 421 has also a whole bunch of packages, so they are all within that. But if you go to a newer version, 4.3.3, it only has like 100 packages, so it matters which version you use. At Rackham, which now is being replaced with Pelle, they were in a bundle package that's called R packages. On Pelle, they will instead be in R bundle CRAN, except for Stringer, which is in R on all of them. But at SPC12 and LUNARC, they also are in the package R bundle CRAN. So how do you run code with machine learning in R? Well, first, the workflow is you check, do I need any R libraries not already installed? So first you would test and run R packages, R bundle CRAN, R bundle bioconductor, and so on, and see if the packages you need are there. If they're not, you install. You determine if you want to run on CPUs and GPUs. There are many of the modules that are not CUDA aware, and you can then either use those or use ones that can run on GPUs. You would then install any missing R libraries. You may want to download dataset if you need that. Then you write a batch script and you submit it. That is the general workflow of how to do it on the SPC sentence. And I have a short example here. And this is taken from this place here. And at some of the centers, you cannot access remote datasets. So I downloaded this dataset as well. And it's located either inside this R tarball or in the R Matlab Julia HPC if you got it with git clone, but otherwise it should be in the R tarball. At most of the centers, you can use it as a remote data set, but at some of them not. So I have made different scripts depending on that. So if you are at NSC, you need to install Caret, kernlab, and random forest before running. And I am showing how to do that here. And this is from inside R. So you load R, start R, install the packages, quit it, and then use R script to run this small example here. And if you are at a center that doesn't allow you to use a remote data set, then you will just remove the comments on this section here to use the local data set, of course, except these comment lines. But this one and this one, you remove the comment on those and then put comment here instead if you cannot use remote data sets. At PDC, there's no problem running it. You just load the R module and the prerequisite, and you can run it. The same as C3SE and UPPMAX also can, I believe, yes. And at HPC2N and at LUNARC. So it's only really if you're at NSC, you need to install some packages. So I'm here at the HPC2N. And let's see. What I did it. Maybe we did it. Okay, I'm going to do this. I had fetched them from inside here, but it is the same that is in the table. So you have this here, iosml.r, and I will load some modules. Not HPC2N, I do a purge first.
This is LUNARC, I guess, the one that you copied from, but it's
It
okay.
did. You're very
Yeah.
right, but I think they are almost the same.
The
But you're
same,
right.
okay.
They are not. They are not completely the same, and that is what the problem was. So you are
Yeah.
right. That was the problem. And it will just take a short time and then it runs it. Normally you shouldn't run anything on the command line, but this was very short and fast, so you can do that. So just get the tarball that should be in the project Matlab 4 courses, or at the NSC, it's in Pro courses for 2025 users and your username. And if you're at NSC, remember you need to install these 3 packages before you can run it. And the same goes that you need to install them before you run them as a batch script, of course. So they will usually have to be run in a batch script, as I said, because mostly it will be quite long. And if you want to do a serial job that does machine learning, then you could run it like this. Just have a script similar to this, and there are ones for each of the centers. And yeah, you just load them and then run it from inside here and just ask for one call. There is little difference in that. It's very much the same in all the centers. The only difference is being your project and which modules are needed, because they are named differently. But these examples should work in all cases. For a parallel job, here again, there are little difference between the centers, aside from the names of the modules and your project ID. And here, since it's a parallel job, you also need OpenMPI. And of course, C3SE are for GPU jobs, so you shouldn't run these then. But there is a script that's available in the directory you got from the tarball, and it is per center, so it's called iros_ml minus and then the cluster that you are using, that is h, and they should be ready to just run if you are in the project course project. So GPU jobs, some packages can be used with GPUs in R. One example is XGBoost, and there is an example for how to install this package and run a test case with GPUs here. There are some prerequisites that depends on your center. At NSC, there is no compatible CUDA and R, so you need to install your own R with Conda if you want to use R with CUDA. And I have tested this and written down how to do this. And it takes a little while, so I would just suggest that you do this when you have a break or something. But you can also start doing this in the background. But this is generally the case on Tetralit, that you install most things yourself. But this way should work to get it to run. On Dardel, it will not work because it's for CUDA enabled GPUs. At C3SE, it works directly. You just load some modules and then that should work for it. And the same at each of the other centers. After that, you also you need XGBoost installed. This R package. So you go into this directory, and if you were not here on the R day, you need to do some setups for R. And those I have here again. So you do mkdir, and then you create a directory where you want your R packages placed. And it should be named R minus packages minus whatever version you have of R. For instance, if you are at HPC2N and you had, let's see, what R version is this? (432), then you would put 432 here. And you would create this package, this directory for it first, and then you would make an entry in the .r environment, which is R's setup file, where it checks for where packages are installed. And you could do that with echo r_libs_user, they have to be capital, equals, and then the path to where you put this directory here. But instead of putting the version at the end, you put %V, because then it will work for each version of R you may use. And then you send it to this file here, which is in your home directory. So that has to be done first. And then you can go ahead and fetch XGBoost, the R package, and install it with this command here. Can go ahead and do this. Let's see if I have R432. I have my package directories here. I don't have one for that, so I'm going to create one. R packages 432, and I already have. Let's put into my R environment. You see, it already has this line here, so it knows where to look for them. And so I'm going to download this here. And I'm going to do it inside of my R plus 432 get.
I
got it twice.
Yeah.
Like that. So I'm downloading it. Then I'm untarring it. And now I can install it. Well, it doesn't matter. I'm going to install it for the version I'm using here. I just want to check I have a plan loaded. Okay, good. So what I'm going to do now is I'm going to install XBoost. And I actually shouldn't have unpacked it, but it doesn't matter. I'm just going to install it. And it will take a little while for it to install. So meanwhile, I can say that in order to run this here, you also need a data file, a data set that's Higgs particles, a data set about that. And it's a very large data set. And I have already done this here. I have fetched it with wget. I have unzipped it, de-unzipped it, and then I put it in this project directory. So it's in project Nobel 4 courses, that is Brydsö, and it's in Pro courses for 2025 users in Tetragit and each of the other centers as well. But you can see it's called Higgs.scv. It's here. And in order to use it, you can go to your work directory. And for me, that is here. And there I'm going to simply do a soft link so it seems to the program that I am located in this directory. It's located there, so I'm going to say ln -s, and then I'm going to take the path to where it is located. Let's call this here, and then I'm calling it Higgs CV. And now I have in the directory where I'm going to run, I have a soft link to this huge data set, which has the name that it's looking for. So it will assume that the data set is there. And then I can use this R script here, TPU script database Higgs. Let's see if I actually put it there. It's there. So this script here is already in the R table. And then there is a job script for each of the centers that you can copy, but it should also be located in this directory here, job GPU. And you use the one that fits the data set that you are at. So if you are at Kebnekaise, then you use this one. And then you just run it, and then you, and I have failed in the markdown here, but you will get some timing output for it. And I'm just going to open this here so you can see how it looks. Like that. And you can see here that it's running on an L40S and it's loading the things it needs. You need to, if you're not doing 442, if you're using 432, then you just need to load suitable modules for that. But whatever you used when you installed this, let's see what was XGBoost, when you installed that, it should be the same modules you put here, and then you can run it. So that, and then there is also another exercise if you have time for it later, and that is using tidyverse, Caret, and Deuterium. And I will just say that you can try and run this exercise yourself later if you want to. because I want to move to the next section, which is for Julia. And the text for Julia is, I haven't had time to actually go through this more, so there are some things that should have been made clearer here. I originally only had a section for R. So in any case, Julia is suitable for machine learning, as you probably know if you're using Julia. So you may wonder if any packages are installed, any machine learning tools, and how you run it. And this is what we're going
I
to
did
look at.
make CUDA run.
You did make CUDA run.
Yes.
Do you want
I just did
to
that.
share screen and try it and try show it?
I may be able to share.
Let me stop sharing and then we can just take a short jump into that, because it might be very good to see.
So I just added these 3 lines at the top of the Julia script. Import PKG, the package manager. Activate an environment, which here I call it temp CUDA, but then I realized it isn't really temporary because it puts it in your active folder and you can reuse it, of course, as usual. So better call it my CUDA environment or something. And then I just do package add CUDA.
You do it inside this. Okay, that's
I do it
because
inside
then
this.
it's of course gets the right one. That's a good idea.
And this add will become a no op when you have it already installed, already added to the environment. But of course, you might learn a little bit by commenting it out when it's done. But you can activate by pausing project dot, as we talked about. There we go. I cannot show it working here because I realize I don't know how to ask for GPU on Pelle. But I did try it on Kebnekaise with an L40S, and it worked.
That's great. That's very good. We should add this for next run of this, because otherwise it only works for the V100, and the reason it works for that is that the login node is the same type of architecture as the V100 nodes has. So it only works because of that. And in the way that you have found here, it will work for all of them, and that's great. So that's what we should do, definitely.
Yep, thank you.
Yeah, it's very good. I was about to talk about machine learning jobs on Julia on GPUs. Julia has machine learning packages that you can install. One of them is Flux, and that is going to be used for a test case, which deals with a data set of tiny images. And in order to do this test example, we should create an environment called ML. And we should do this. Just go into the Julia directly. And I will do a budget patch to get rid of my packages. And then I will load Julia. And I'm going to go with the versions, this Julia version here. This example is like the other, it's going to run on V100. So it's probably going to take a while before it starts, but otherwise we need to change the CUDA version, and we could do that like this.
For my test, I used Julia version 1.9.3 and the CUDA version 12.6.0.
I will take a newer Julia version. So then I will get this flux from the flux vector, fetch the VTG. I'd like to do that. And I should also create a environment called ML. And I should have fetched it there, so I will do that. For that ML. And then I will go into ML. I will start Julia. And then I wanted to add CUDA. It's going to take a while. It usually does. But I need to add the CUDA and ML datasets and ML utils. When I have done that, I am going to use this dataset that it wanted to download and accept. I already downloaded it, so it's probably, hopefully, going to see it there. And then I'm going to train with that. And I can change it from 50 to something shorter, which probably is a good idea because otherwise we're going to sit for a long time. Let's see what time is it. It's already 3 o'clock, so I'm not going to run through this. Because as you can see, it's not even finished installing CUDA. But when you have done this, you can submit the job with this script here. And we need to change it to fit on, I believe this is for either Rackham or SPC2N, but you can change it fairly easily to run on all the other centers. We just mainly need to change the line for how to ask for GPUs to fit with what we did on the intro to GPUs. And then load the suitable version of Julia and the suitable version of CUDA for that. And there are only examples for SPC2N and UPPMAX because this is an older example that I haven't had time to update. It's still not finished installing. Okay, so let us continue with the machine learning with Matlab. And here in this course this time, we're only going to give one example of how you can run a machine learning script in Matlab with a neural network model. And this is one we have here. And there's a data set that we need as well, and that is present in the exercises for Matlab that you have downloaded earlier today or on the day with the Matlab. And it's going to the exercises, to Matlab, and to wine.csv, that is the data set. That's this one I have here. And there is some graphics that you need to display, or at least if you want it to look nicer. And because of that, you should either run this through Open On Demand or through a thin link, or perhaps just regular shell, but with an X11 server. And I think it's easiest if we do this through Open On Demand, and I'm going to show this for UPPMAX at ASP.NET. So I will start portal. This I misspelled it. It's with an A. Tau. And then I log in. To ends. Open On Demand. Nope. And I go to interactive apps, and then I pick Matlab proxy. I'm going to run in the compute project that we used for this course. And I will pick 1 hour because I only just need to start this up. So I actually don't need that much, but we'll run with that. And we'll use any GPU. And we're starting in the project storage directory for the course. So let's launch. It'll take a little while we're getting resources allocated. And now we have them, so I'm going to connect to Matlab. And as we mentioned earlier, when you are running it through the Open On Demand, you are running on the resource that you get allocated and not on the login node. So that means that you can safely run stuff here. You're not annoying anyone else with it. So you're actually running it like a batch job, but just interact. And this here, that is this Matlab script here. And I'm going to try and run it. Sorry, this one here. I just copied it into Matlab and named it something. I just called it mymlscript.m. And then I'm going to type run. And I am in the wrong directory. So it was this one. What is running now? And as you can see, it's doing the training. And it's doing 2,400 iterations, but it's doing it very fast. So it should be done in a very short time. When now it's done. Now I'm going to close this just so I can see what results I got otherwise here. So here we have the predicted versus true values. And down here, we have the training, how it went here. So various iterations, how long it took. So it went quite fast, and you can try and compare it to what when you run it yourself, you can compare it here and see if you get the same values, and you can try and run on different, for instance, on a CPU or on a GPU or on another HPC center. But yes, it ran as it should, and we got some results. So I would suggest that you yourself go ahead and try this exercise. And if you haven't already, you should also try the R exercise. And yeah, after that, you could also try the Julia exercise, which should. So, and yeah, if you have more questions, then you can ask them on the Q&A document, which we will monitor until Monday. And otherwise, just ask us questions here today, or you can send questions to the support at a later point. So I'm going to stop here.